So I want you to imagine the biggest tech boom in history, right? The AI gold rush. We are talking about hyperscalers like Amazon, Google, Meta, Microsoft. They are planning to spend a staggering $700 billion in a single year on artificial intelligence infrastructure.
It is a massive, almost incomprehensible amount of money.
Right, but here is the crazy paradox. Despite all those billions, U.S. data center construction actually shrank recently by 5.7%, and that is the first time it's dropped since 2020.
Yeah, which makes 0 sense on paper.
Exactly. So we're doing a deep dive today to figure out why, because the short answer is you just cannot run limitless AI ambitions without copper, steel, and, well, a functioning power grid.
You really can't. And what we're looking at is this impending collision between the digital cloud and just hard rusting physical iron.
Right. And to unpack this, we've pulled together a really diverse stack of sources. We've got grid operator reliability reports from ERCOT in Texas, PJM in the Northeast. We're looking at legal guides on data center energy procurement, electrical equipment trade analyses, and even some deep dive investor forums.
Our mission here is to basically synthesize all of this. We want to show you why the digital cloud is crashing into physical bottlenecks, how this directly impacts the actual electricity grid you rely on every day, and, the desperate ways these tech giants are trying to bypass the physical limits.
Yeah, desperate is the right word, because this disconnect between the capital they have and the physical capacity to build is wild. Like, we mentioned that $700 billion figure, but when you look at the real estate, data center vacancy is at a historic 1%.
Just 1%.
Yeah, and 92% of the capacity currently under construction is already pre-committed. It's spoken for before the concrete is even poured.
Which leads to some pretty startling financial disclosures. Like in the investor sources, Microsoft recently disclosed an $80 billion backlog of Azure orders.
$80 billion.
Yeah, $80 billion of guaranteed revenue that they just cannot fulfill.
Yeah.
Because they literally can't get the electricity and the physical space to power the servers for it.
I mean, it's like designing the world's most advanced, expensive race car, but forgetting that there's a global shortage of asphalt to build the track. Why can't all this tech money just instantly buy a solution?
Because you can't just print heavy manufacturing pipelines like you print code.
Right.
A modern AI data center isn't just a warehouse full of laptops. It requires massive, highly specialized electrical equipment, and the biggest bottleneck right now, the high voltage power transformer.
Yeah, because a transformer is literal iron and copper. It's old school heavy industry. And looking at the trade analyses, before the pandemic, lead times for standard power transformers were like 30 to 60 weeks.
Which was already a wait.
Yeah, but now that average has exploded to 128 weeks.
Oh, wow.
And if you need a generator step-up transformer, those are the massive house-sized units that take raw power from a plant and step the voltage up for transmission lines. You are waiting 144 weeks, sometimes up to 4 full years.
And naturally, with wait times like that, the prices are just surging. Distribution transformers are up something like 78 to 95%, and large power transformers are up 77% just since 2019.
Which is insane, but why can't they just build more factories to make them?
Well, the raw materials are the real choke point here. These transformers rely on something called grain-oriented electrical steel, or GOES.
Right, GOES. And that's not just standard steel.
No, not at all. It's a highly specialized silicon iron alloy. You have to manipulate the crystal structure of the metal so the magnetic properties align perfectly. That's what lets the transformer change voltage without losing a ton of energy as heat.
Oh, interesting. So you need a specialized foundry for that.
Exactly. You can't just retrofit a regular steel mill. And here is the kicker. The U.S. relies on exactly one domestic producer for this stuff.
Cleveland-Cliffs, right?
Yes, Cleveland-Cliffs. Because of that single domestic source, the U.S. actually has to import 80% of its large power transformers.
Which is a massive vulnerability. Okay, so even if a tech giant throws money at the problem, gets the imported steel, waits 3 years for the transformer, they still have another wall to hit. Labor.
The workforce wall is huge. The construction industry overall is short about 439,000 workers right now.
Yeah, and building an AI mega campus is not just pouring concrete. You're installing super dangerous high-voltage systems, massive liquid cooling setups.
Right, you need highly specialized technicians. And the sources point out that data center projects are paying a 32% wage premium. They're averaging around $81,800 a year just to pull talent from other sectors.
But it's not enough, is it?
No, because a single multi-gigawatt mega campus might need a peak crew of 4,000 to 5,000 workers on one site.
That's a small town of just electricians.
Exactly. Finding 5,000 skilled tradespeople in a single local market when there's a national shortage, it's mathematically impossible. So projects just stall out.
It's so ironic that cutting-edge AI is being held up by old-school materials and a lack of local electricians. But, okay, let's say they pull off a miracle. They get the steel, the transformers, the 5,000 workers, and they finish the data center. What happens when they go to plug it into the wall?
That is where the entire system hits a tipping point. The existing power grid is practically buckling. Let's look at PJM, for example.
And PJM is the largest grid operator in the country, right?
Yeah.
Northeast, Mid-Atlantic.
Right. 13 states, 60 million people. Between the massive new data center load and the rapid retirement of older fossil fuel plants, wholesale power costs in PJM jumped 54% in just 1 year.
54%.
Yeah, up to $67 billion.
Yeah.
And their capacity costs, which is the premium they pay just to ensure backup power plants are available, that surged by 262%.
Oh my God.
And even with those price hikes, in PJM's recent capacity auction, they cleared 6,517 megawatts short of their reliability target.
Let me translate that for a second. Clearing short basically means the grid operator said, we need X amount of power to keep the lights on during a blizzard, and the market essentially replied, we don't have it.
Yeah, they literally came up empty.
Yeah.
And it's not just PJM. If you look down south at Texas, the ERCOT grid is facing the same thing.
Right. The ERCOT reports, demand in Texas is surging, but their dispatchable thermal assets like coal and gas are retiring.
Yeah, and the Texas Public Policy Foundation modeled what would happen if a 1 in 10-year winter storm hits ERCOT in 2030.
The results were terrifying.
They really were. The model projected over 72 hours of rolling outages, 700 gigawatt hours of unserved demand, and it would cost ratepayers about $14 billion.
But wait. I want to push back on that ERCOT fear for a second, based on the queue data and the sources.
Okay, go for it.
If you look at ERCOT's interconnection queue, the waiting list for new power plants to connect, they have about 426.9 gigawatts of capacity waiting in line, and it's overwhelmingly green.
Right, it's mostly wind, solar, and batteries.
Yeah, like 38.2% is battery storage and 35.6% is solar. Natural gas is only, 14.4%? So if the queue is packed with over 150 gigawatts of solar and 160 gigawatts of batteries, why are we worried about outages? Doesn't that massive influx solve the problem?
It seems like it should, right? But it comes down to a concept called capacity accreditation, or ELCC.
Okay, what is that?
So ELCC measures how much firm, reliable power a resource can actually guarantee during a worst-case scenario. Batteries are great for daily cycles. Think of them like a bucket.
Okay, a bucket.
Right, the sun shines all day, fills the bucket, sun goes down, everyone turns on their AC, you empty the bucket. Works perfectly for a summer evening peak.
Oh, I see.
But a multi-day winter storm, it breaks that cycle completely. If it's freezing for 72 hours, the sun isn't shining enough, the wind drops, and after maybe 4 to 6 hours, those batteries are dead. The bucket is empty.
And there's no hose to refill it because the solar panels are covered in snow or it's just too cloudy.
Exactly. What the grid desperately needs to survive a 72-hour storm is firm, dispatchable power. Stuff that runs 24/7 regardless of weather, gas, coal, nuclear. But those take years to build, and right now, as we saw, they're retiring faster than they're being built.
Wow, so the grid is unreliable and wildly expensive right now, which naturally means these tech companies are trying to find loopholes to bypass it, and that is causing some massive local backlash.
Oh, huge backlash. Communities are not happy.
Yeah, the legal guide showed that $64 billion in data center projects have been blocked or delayed recently by a wave of 54 local moratoriums.
Because local zoning boards are freaking out about the water usage for cooling, the constant noise from the HVAC systems, and obviously the grid strain.
So if you're Amazon or Google and the public grid is full and local governments are blocking you, what do?
You try to skip the line.
Right, the behind-the-meter loophole. BTM.
PTM is a fascinating strategy. Instead of waiting years in an interconnection queue, you just build your data center directly next to an existing power plant.
You literally plug in right at the source, behind the utility meter, before the power ever hits the public grid.
Exactly. And the big test case for this was Amazon. They tried to pair a 480-megawatt data center directly with Talon Energy's Susquehanna nuclear plant in Pennsylvania.
Which sounds like a brilliant hack for Amazon to get clean, firm nuclear power. But the government wasn't having it.
Now, the Federal Energy Regulatory Commission, FERC, they stepped in and unanimously rejected the Amazon Talon amendment.
Why?
because they realize that if tech giants start hoarding power from existing baseload plants, that power is no longer flowing to homes and businesses.
Right.
So the grid operator has to scramble to find replacement power to keep the lights on. And that replacement power is usually more expensive, less reliable, or dirtier.
FERC's ruling basically dropped the hammer. They said tech giants cannot hoard power without paying for system-wide grid upgrades. They mandated that these loads have to pay gross ancillary service charges.
Yeah, meaning they still have to chip in for the upkeep and balancing of the broader grid, just like everyone else.
And worse for the tech companies, FERC ruled they will face curtailment during emergencies. Like, if the region is having a grid failure, the data center gets cut off so the local hospital can stay online.
They can't just isolate in their own little nuclear bubble while the rest of the state goes dark.
It's an unstoppable force meeting an immovable object. Big tech versus federal regulators. So if they can't rely on the public grid and the government won't let them hijack a nuclear plant, what options do they have left?
Well, they're being forced into some radical geographic and technological shifts. The neo-cloud hustle, basically.
Let's start with geography. Traditional hubs are tapped out, like Northern Virginia Data Center Alley. It's hit a hard physical and land ceiling.
Right. So now Texas is actually projected to overtake Northern Virginia as the world's largest data center market by 2030.
Purely because Texas has an independent grid and lots of open land. But moving to Texas doesn't solve the core physics of power generation.
No, which is why the tech shifts are way more important. Since they can't use the grid, they are going completely off-grid with massive microgrids.
Oh, like Oracle. Let's talk about Oracle's Project Jupiter in New Mexico. That case study is wild.
It really is. Initially, they were going to use standard natural gas turbines, but they ditched that entirely. Now, they are planning to use up to 2.45 gigawatts of Bloom Energy solid oxide fuel cells.
Which is huge. And for those who don't know, solid oxide fuel cells don't burn gas to spin a turbine. They pass natural gas through a ceramic material to create a direct electrochemical reaction.
Right, no combustion.
Exactly. So it saves massive amounts of water, and it reduces no-NOx emissions nitrogen oxides that cause smog by 92%.
It's incredible technology. Everyone talks about small modular reactors, SMRs, or next-gen geothermal as the future of AI power.
But those are years, maybe decades away.
Exactly. Fuel cells are happening right now out of pure desperation. And this desperate scramble for power is completely changing how investors look at these companies.
The rise of the neoclouds.
Yeah. In the Motley Fool discussions we looked at, they were analyzing AI infrastructure companies like Nebius, CoreWeave, and Iron. And the whole conversation hinges on a crucial difference: contracted power versus active power.
This is so important. Contracted power is basically just a promise, right? A piece of paper saying a utility will eventually give you electricity in, like, 5 years.
Yes, it's future potential. But active power, that means the facility is built, the servers are humming, and they are generating annual recurring revenue right now.
And the sources pointed out Nebius as an example. They talk a big game about having 1 gigawatt of connected power.
Right, but when you look under the hood, their actual active power is only around 170 megawatts.
Oh, wow. That's a massive difference.
It is, because right now, power is the ultimate proxy for execution in the AI race. Any CEO can get on stage and pitch a software stack. But active power is the source of truth. It proves you actually navigated the transformer shortages, the moratoriums, and the grid limits.
Which really brings this whole thing full circle, right? Because zooming out from all this corporate maneuvering, the reason you, listening to this, should care is that this isn't just happening in the cloud. It's happening in the physical world.
It's up here.
When wholesale power costs jump 54% in PJM, or ERCOT's grid reliability drops in the winter, that eventually hits your local utility bill. It impacts the stability of the electricity powering your home.
The core theme here is that the AI revolution isn't a software revolution anymore. It is fundamentally an infrastructure and energy revolution.
Right.
The digital world has hit the limits of the physical world.
Which leaves us with a final kind of provocative thought to mull over. If securing gigawatts of electricity and building massive power plants is now the main bottleneck for AI, what does the future of big tech actually look like?
That's the billion-dollar question.
Right. Will the tech monopolies of tomorrow look less like the nimble software companies of the past and more like standard heavy industry power utility companies? We'll leave you to think about that. Thanks for joining us on this Tech Dive.
Thanks for listening.